let's take a look at some of these introductory vector and scalar problems. And for the very first question, I have a definition problem. So for this problem, which of the following contains vector quantities only? And vector quantities have both magnitude and direction. And just for some good practice here, it might be good to kind of label everything in this list as a scalar or a vector. So mass here is a scalar. Speed is also a scalar. Energy is also a scalar. And then velocity is our first vector. Displacement is also a vector. Energy is a scalar. And for option D, displacement is a vector and velocity is also a vector there. So option D has all the vectors there. Okay, moving on to question number 2, we have another definition question. So which of the following is not a vector? So if it's not a vector, then it must be a scalar. So a scalar has magnitude only. So mass is a scalar, but impulse is a vector, velocity is a vector, and momentum is also a vector. So the best option here is A. So mass is a scalar. Question number 3, which of the following statements concerning vector and scalar quantities is incorrect? Okay, so incorrect means we're looking for the false statement. So option number A, all scalar quantities have direction. And this is false, right? So scalars have magnitude only. But let's go ahead and just confirm all the other options here. So all vector quantities have direction, which is true. All scalar quantities have magnitude, which is true. And vector quantities have magnitude, which is also true. So out of all the options, A is incorrect. Okay, let's move on to some vector addition problems now. And for question number 4, we have an aircraft that's flying due west. All right, so when you're flying due west, that means you're kind of going in the left direction like that. And then sometime later, the aircraft is now flying due north. So due north is going in the upwards direction like that. And which vector best represents the aircraft's change in velocity, right? So change in velocity is delta V. Okay, so before we do this question here, just recall that a change in velocity, which is delta V, is defined by your final velocity minus your initial velocity. Okay. In terms of vector components, it might be good to also write this as your final velocity plus your velocity in the negative direction like that, which is mathematically the same thing. And the way we kind of implement this negative v naught vector is that we go back to your due west vector, which is your initial velocity. And if you want to change this to a negative vector like that, all you have to do is just change the direction like that. So make it go east now. Okay. All right, so let's go ahead and put the vectors together. So I'm going to use a different color here. I'm going to use blue here. So I need my final velocity, which is right here. So I need this vector right here in blue. And I also need my negative initial velocity vector like that. Okay, so if I put this all together here, let me go ahead and write out my final velocity vector like that. So this is your final velocity vector like that. And then if you attach this is your negative v naught vector. And in order to create your resultant, you kind of start at the tail position here and you just connect it to the head of your second vector right there. And this right here is your change in velocity right there in red. So that red vector right there is the change in velocity. So option A would represent the change in velocity. Okay, let's move on to question number 5 now. I believe question number 5 is a very similar problem. We just kind of changed the direction of the vectors. So we have an airplane again, which is flying eastward. So eastward technically means you are going to the right. Okay, so this is your initial velocity vector. And then sometime later, I guess we're flying southward at the same speed. So southward is now going down. So this is your final velocity vector. And which vector shows the airplane's change in velocity, right? So change in velocity is delta V. Okay, so just like in the previous problem, we know that delta V is equal to your final velocity plus your initial velocity in the negative direction, right? So if we want to capture this part of the problem here, negative V naught, we just take your V naught over here and we make it negative by putting a negative sign like that. And then we just switch the direction from eastward to westward. Okay, so now we're going to be using our final velocity vector in green and our negative initial velocity vector in green there, and we're going to create a resultant vector now. Okay, so how do we do that? So this is your final velocity going southward, and then we have our negative v naught vector going in the westward direction. So this is negative v naught. And our resultant vector always starts at our final velocity vector from the tail and goes to the head of our negative v naught vector. So this is delta v right there in red. And if I match that with the options that are available, I guess option D would be the best option there. So there's your delta v there. Okay, let's move on to question number 6 now. For question number 6, I have two velocity vectors, v1 and v2. And I need to figure out which of the following best represents the resultant vector. So you're adding the two vectors together. So this one's actually not too bad. You take this green vector right here. So I'm going to just redraw it like that. So that's v1 with the hat. And then we just add our second velocity vector like this. So we just add that. So that's v2. And our resultant vector starts at the tail here. And we just connect that to our second velocity vector, and this is our resultant right there. So option C best represents that. So yes, the arrowhead has to be in the top right hand corner there. Okay, so we move on to question number 7 here. Question number 7 is good because we're just seeing if you understand how to add vectors here, and which of the following vector diagrams shows vector A as the sum of vectors B and C. So we want to figure out which diagram has A equals to vector B plus C. In this case, I guess A is your resultant vector, right? That's the result of adding vectors B and C. If I look at option number A, we're going in this direction, and then we're adding the B vector like that, and then our resultant vector is here in black there. So in diagram A, this is really vector A plus vector B equals to vector C. Okay, so that diagram represents that, which is not what we're looking for. So we move on to the next one. For the next one, I kind of see that we have vector B here, and then we're adding vector C, and then we get our resultant vector, which is vector A. So if I look at option B here, this would be the B vector plus the C vector, and that equals to the resultant vector, which is A. So it looks like option B is what we're looking for, but let's go ahead and finish off option C and D and just make sure we understand what's happening with the vector additions here. So for option C, the blue arrow is going down, and then it looks like we're adding the A vector there, and our resultant vector is actually C. Okay, so for option C, it's really vector B plus vector A gives you vector C. Okay, and let's move on to letter D here. So we have vector B going the downwards direction, and then we're adding vector A, and it looks like vector C is the resultant vector here. So for option D, it's actually vector B plus vector A gives you the resultant vector, which is vector C. Okay, so that's how you break down every single one of those options, and from those options, option B satisfies the condition that we're looking for right there. Okay, let's move on to another question here, and let's see if we can just finish off this homework video here. So question number 8, two forces act on an object as shown in the diagram, and which of the following best shows the resultant vector of these two forces? Okay, so we're just adding this green vector and this blue vector, right? So if I just redraw that over here, here's force 1, here's force 2. So this is your green vector, this is your blue vector, and just like the previous problem, it's the resultant always just connects the two vectors like that. So this is your resultant vector right there. And I believe option C here? So option C would be our best answer for that one. Okay, so that concludes this very short introductory video on vector and scalar and just some vector addition methods here.